Thank you. All right, yes, so we're talking about the continuum between infrastructure as a service and platform as a service, and how together as developers we can explore finding the sweet spot between these two models. Again, my name is Ryan Boyd. I'm head of developer relations for the Google Cloud Platform. We'll have plenty of time here for Q&A, but if you have any questions that don't get answered during Q&A, you can feel free to reach out to me online via my Google+ or Twitter handles that are shown here. I do just want to give you a little bit of intro to my background so you can see where I'm coming from with this talk. I've been at Google now for about 7 years, worked on everything from our Google Data APIs, such as the YouTube APIs and Picasa APIs, through building out an ecosystem around Google Apps, and most recently, obviously, on the Google Cloud Platform side. Before that, I spent about 6 years doing these things. I spent about 6 years building out Apache web servers, application servers in JBoss or Tomcat, configuring single sign-on systems, configuring video servers, monitoring systems, all these types of things. And this was all done for one very simple purpose. The simple purpose was that so myself and others on my team could launch web applications. It's a lot of hard work to build those systems that would scale, have the security and redundancy and that sort of thing that we were looking for, all so that we could launch a very simple web application. Now, I want to give you a short history of launching an app. Many of you are probably familiar with this history, but just to recap where I'm coming from. Back in 1999, if you wanted to build an application, web application, you likely got a bunch of funding. You bought hundreds of thousands of dollars worth of servers, networking gear, stitched it all together, put it in a colo space, and then hired system administrators. And those system administrators installed and configured the web application stack, carried pagers, dealt with anything that went wrong with the web application stack or the hardware, the networking gear, all of that, again, just so that they could launch a web application. Now, things developed from there. Things got a little bit better. You started to have places that you could rent servers from, that the hardware was already there. You could rent them by the month or with a year contract, that sort of thing. You started to get some shared hosting environments, but that didn't provide enough isolation for many developers and many types of applications. But then in 2008, we started to have the ability of VMs as a beta service in the cloud, where you could purchase virtual machines on demand and have much fewer capital investments when you're building your applications. Of course, you still had to hire the system administrators. System administrators still needed to configure the OS, needed to configure Apache and MySQL and your proxy servers and caching servers and all of the other infrastructure, and they still need to carry pagers. Now, the same year, Google actually launched Google App Engine. And Google App Engine was our way of saying that developers should not have to deal with all of this, should not have to deal with system administration, should not have to deal with scaling applications themselves, things like that, all so that they could build an application, a web application. We wanted the ability to give developers the concentration that they wanted. They wanted to concentrate on building their differentiated business logic, concentrate on building what sets them apart from their competitors. So it was a fully managed platform, had auto scaling, versioning, had local developer tools that you could build in before deploying to production. And all of this was done within sort of a sandboxed environment. A sandboxed environment that was necessary in order to allow for this auto scaling, but a sandbox environment that made sure that you were running safe code for the environment. But it had a set of managed services that made it a lot easier to build the applications. It wasn't just about concentrating on the web application side. It was about reuse of existing services that Google had built up over many, many years. Google's been in business now for about 15 years, building these types of services for our own company. And so App Engine was an idea of exposing that for you as developers, having a web application server, or a web server and application server, having a data store, a NoSQL-based data store that scaled with your application, having integration with Google accounts so that you did not need to configure your own single sign-on system, having an outbound email service, you didn't need to configure SendMail, For those of you who've done all this, it's kind of a pain in the butt to do, configuration of all these different services just to launch a simple web application server. So that's what App Engine was there to solve. Make it really easy to build your applications, easy to scale. This results in developer efficiency. Developers want to be focused on that core business logic that differentiates their application, and App Engine provided that. Now, if we step forward into 2009, 1 year later, a car-sharing company called GetAround was participating in a hackathon. How many are familiar with GetAround? All right, not too many, but think of something like Zipcar or City Car Share. And they're building an application in a hackathon to allow you to rent out your car. And they spent 2 hours building that application on App Engine, a prototype of that application. Now, if you step forward, it takes a while to build a business. In 2011, they launched that application at TechCrunch Disrupt, and they won the TechCrunch Disrupt contest. And as part of winning that, they got a huge spike in traffic. And that huge spike in traffic came and continued to have growth, but all the while, the developers of the application didn't need to do anything. They were literally on stage breaking open a bottle of champagne. Unfortunately, don't have the picture on this slide, but they were literally drinking champagne, never got paged once, never had any problems with their application. That is what developer efficiency is about, allowing you to build new and innovative things without having to focus on the underlying system infrastructure. So meanwhile, we launch more and more managed services. We take more and more of the Google infrastructure and expose that to developers. So we launched a blob store. The blob store allows you to store any arbitrary binaries, often used for image serving and that sort of thing. Memcache to improve the efficiency of data store requests by caching in memory, obviously the frequently accessed items from the data store. Task queues to allow you to manage the workflow of your application, and then image APIs and other things that really take Google's core underlying services and allow you to reuse them. And not only are you reusing the software, which you can get via libraries, but because these are managed services, we're automatically handling the scaling and the redundancy and all of that. We like to call it meteorite level redundancy. If a meteorite strikes one of our data centers, the plan is that all of the services keep on running, even in that case. So your application keeps on running. You can still be on stage celebrating with a bottle of champagne, which hopefully you all get to do. We also launched more languages on App Engine about that time. So we launched Java support and we launched Go support. Originally with App Engine, being a sandbox environment just with Python, there was a limited audience of people who either knew Python or wanted to learn Python. So we definitely put a lot of work into launching new languages. But developers still wanted more. Developers wanted to work with a database that they were already familiar with. Instead of being asked to use a NoSQL paradigm database, they wanted to use a SQL database that they already understood. Different scaling properties and that sort of thing, but MySQL was one of the common databases that people requested. And so we launched Google Cloud SQL as a managed service to allow developers to do this. They wanted to step outside a little bit of the sandboxed environment, have outbound socket connections. They wanted to make requests to arbitrary external APIs that weren't over HTTP, things like IMAP services. So we launched the socket API. They wanted longer running processes. So App Engine initially, is focused on front-end serving, is focused on super fast requests for really high scalability. But developers wanted to have the ability to crunch data or run other processes that were longer running. So we launched background services. And they wanted control over scheduling. Again, it was focused on front-end requests. And some languages, particularly in things like Java, the startup time that it takes to launch a new instance is a little bit too long for some users to wait for if those users are expecting responses in milliseconds or tens or hundreds of milliseconds. So we allowed developers to configure the minimum idle instances that were available for their application. So this is all great. We can take the platform as a service environment, a managed sandbox service, and keep on expanding it with some of the top requested features that developers were looking for. And this served a lot of needs. But there's still one remaining thing. This is a screenshot of our documentation at the time. I love archive.org. It's a great way to go back, even on projects that you've worked on. It's a great way to go back in history and look at the documentation. And you can see here this JRE class whitelist. This does remain today, but this is a screenshot from back then. And the JRE class whitelist is just that. It's a list of classes that you're allowed to use in App Engine in the sandbox environment. And you get a huge amount of benefits from this sandbox environment. The auto scaling, you get the managed services that allow you to build and run your application really easily and not have to worry about the system administration. But there are a set of classes which you're not allowed to use because they're not on this JRE class whitelist if you're in Java. And what do we do about that? How do we allow you to run any type of code you want? How do we allow you to run that code in any language that you want? Well, in 2012, we did just that by launching virtual machines on Google's infrastructure. People who are using App Engine and other customers wanted the ability to run arbitrary Linux virtual machines to move things from their on-premise data centers or to build new applications in languages or with technologies that they already understood. Let's say they're familiar with Redis as a database. They want to be able to run that on Compute Engine, and it won't run in sort of the sandbox environment that's available with App Engine. So this gives you the high data security, also gives you the green computing that Google builds into its data centers, but gives you, first and foremost, this arbitrary Linux virtual machine that you can run anything that you want. So we have the ultimate in flexibility. Ultimate in flexibility with the infrastructure as a service environment, ultimate in developer efficiency with the platform as a service environment. Now that's not the end of the story. We really don't want this dichotomy. We don't want to have to choose between infrastructure as a service and platform as a service. But that's what we had at the time. We had our infrastructure as a service offering, our platform as a service offering. And then, of course, Google for a lot of the applications that we build on some of this technology, as well as some of the core technology that this is built on top of. We build a lot of SaaS applications, such as Gmail or Maps or other applications. And Google's doing this all within our data centers that we've spent the last 15 years building up. And these data centers are actually this beautiful. These are real photographs of our data centers. They take a lot of pride in the colors that they use and other things. But we've spent a lot of time building up expertise in how to manage these data centers and how to deal with fast input and output speeds, how to deal with great networking, how to deal with storage, and how to deal with redundancy. We also spent a lot of time building software. The software, is the things that are underlying all of the services that we've talked about today, and the services that we'll talk about in the rest of this presentation. Things like GFS, which is where we store our files, or Dremel, which is the underlying Google technology for something like BigQuery, or Bigtable, which is our data store. A lot of these technologies, Google is really advancing the computer science here. And so we're thinking about how do we advance the computer science between infrastructure as a service and platform as a service? How do we find that sweet spot? Meanwhile, we're launching more and more languages for our platform as a service. We didn't really stop and say, we've launched platform as a service, we've launched infrastructure as a service. We still are looking at what developers are looking for. And unfortunately for some of us, or fortunately for others, developers want PHP. When I first started at Google, a little aside, I got tagged as the PHP guy because I had done some PHP development. That led me to be writing about 20,000 lines of code of PHP within a few quarters. I don't want to do that again, but developers do love PHP in many cases, and so we wanted that support on App Engine. We're also launching more and more managed services. We're exposing more and more of that expertise that Google's developed over 15 years to do things like traffic splitting. What if you want to canary certain new functionality of your application and you want to make sure that only a few percentage of your users see that new functionality so you can test it out and look at the logs and things like that? Traffic splitting makes that really easy. Doing that in other environments is a little bit more difficult. We also launched modules as we were getting larger and larger development teams that are working with App Engine, maybe across multiple different languages. We wanted the ability for them to control what different team members had access to, as well as allow them to use these multiple different languages within the same application. So we keep on advancing the platform as a service, keep on advancing the infrastructure as a service, and as of 2013, this is what our platform looks like. We have compute, we have storage, and we have application managed services. All right, we also have an underlying bridge that kind of pulls all of this together with our networking fabric, with Google's backbone. But we have these distinct compute services still. So that still shouldn't be the end of the story. We shouldn't have these distinct compute services, because if you look at this step function, developers can get super high efficiency by using a platform as a service such as App Engine. Makes it really easy to build their apps. But what if they just have a few things that they want to run that don't fit within the sandbox of a platform as a service offering? Well, they have two choices. One, they can move all of their application over to infrastructure as a service, and it, basically have that full step down in developer efficiency in order to gain the flexibility to run any type of code they want. They can also use multiple of these services together, but even if they're doing that, they're taking a step down in order to run one part of their application on the infrastructure as a service. They're losing that developer efficiency in order to gain the flexibility. We want it to be more like a curve. We really want there to be a smooth line, and this isn't so smooth. Frankly, it's really hard to draw an arc in all the tools that I've used, but you can see a little bit of points here. But we wanted there to be a smooth line between the platform as a service and the infrastructure as a service. We didn't want you to have to do that step function. We didn't want you to have to do that very large step function, at least. We want you to be able to smoothly bridge the gap, go along the continuum between platform as a service and infrastructure as a service. So how do we do that? Well, we launched in a public testing mode. You can find this out there on the web. You can apply for the program. A thing called VM-based backends, which is our way of exploring finding that sweet spot on that continuum. And VM-based backends are just that. It's basically virtual machines. It's compute engine virtual machines that allow you to run any arbitrary type of code that you want, but within the framework of App Engine. So if you look at the left on number 1, first of all, how many of you have used App Engine before? Okay, a handful of you. You'll notice the YAML files here. The YAML file is a basic configuration file for App Engine. And we have a application called our photo feed application here. And there's a front end, which is serving all the outbound web requests. And then we have a back end on the bottom. And those are the two configuration files that you see here. And the back end configuration file has one simple bolded flag there saying VM true. Just a Boolean value saying run this backend service as a virtual machine. What happens here is in number 2, we're deploying the application to production with the app config update command. So you do this in your local development environment and you deploy to production, and it launches this virtual machine. It launches a compute engine based virtual machine to handle backend requests for the application. This is accessible via URL. And though it is typically, handling things like task queue processing and other things at the behest of the front end application. But this backend is special. This backend is not just a vanilla virtual machine on Compute Engine. This backend has access to all the different managed services that App Engine provides. It has access to things like the data store and the memcache and task queues and logging. These things are accessible through pretty fast RPC-based APIs, the same type of APIs that App Engine is using underneath. And we also do our best to locate these services, or locate your VMs really close to your App Engine app so that these are as high performance as possible. And we're managing these backends. These backends could exist up for about a week, but we automatically manage if it needs to come down, we bring it back up, etc. And having access to all of these same underlying managed services gives the developers the efficiency that they're looking for. But we also have the flexibility. We have the flexibility to run any type of software. So you can see here the configuration file has been modified here to say VM settings, and we have apt-get commands that are running on the Debian virtual machine when it starts up, and we're saying we're going to install RabbitMQ and we're install Redis. And then when App Engine orchestrates these virtual machines and sets up these virtual machines when we deploy our application and manages them, it automatically makes sure that as a startup script, it runs these apt-get commands and installs this open source software. So that gives us that flexibility. We have the efficiency of accessing, any of these App Engine-based managed services, but we also have the flexibility of running any type of software we want. We no longer have the JRE whitelist restrictions. We no longer have the restrictions as to which Python modules we can use. We can use native resources, native memory and CPU and networking and disk, and we can run any type of code we want. C, C++, Scala, whatever you want to run will run on these virtual machines. You have access to a huge number of different types of virtual machines. Because this is using the underlying compute engine infrastructure, there are 22 different types of virtual machines for compute engine, everything from high memory to high CPU, and you can choose the number of cores and the amount of memory and that sort of thing. You have that flexibility just by specifying the machine type in your configuration file in App Engine and then just redeploying your app. You also have the flexibility to manage these virtual machines via SSH. So if you're debugging something, if you have an issue that's going on with your application, the virtual machine backends will actually log to the App Engine logs, but sometimes you want access to the native logs, especially if you're running some sort of native applications that aren't kind of hooking into App Engine's log infrastructure. You want to SSH into these machines. So what you can do is actually move one of the backends or several of the backends into an unmanaged pool. And what that means is that App Engine won't automatically restart these things. It won't scale them up, scale them down. App Engine won't do the OS updates or anything like that as they're in the unmanaged state. But then you can SSH into these machines just like you would any other Linux-based virtual machine. And you can edit the configuration. You can look at the logs. And then once everything is finalized, you can update again and pull it back into the managed pool. You also have the ability to scale these. So one of the key benefits with front ends that App Engine provides is the auto scaling. We don't yet do auto scaling on these VM-based backends, but we do allow you to scale them yourself. You can scale them in two ways. One is declaratively. You can specify in that App Engine configuration file that you want 6 instances of this application running, for instance. And in that case, you just do an update of your application and it redeploys, and you'll have 6 instances of this virtual machine backend running and accessible for your application. Any requests that are made over HTTP to these backends, those requests are load balanced automatically by App Engine using the standard App Engine web stack. And so, any instances that are running, will automatically spread the load across them. So this is the declarative way, but you can also programmatically scale these VM-based runtimes or VM-based backends. This is using the Modules API in App Engine. The Modules API allows you to set the number of instances that exist for your backends. And so you can simply say, this is the backend, this is the version of the backend, here's how many instances I want, and programmatically scale that out. So this is really important for orchestrating the workload from your App Engine app. Your App Engine app can do things like run cron jobs, and those cron jobs can look how long are the task queues, how many tasks are waiting to process, how long have they been waiting to process, and based off of that, you can automatically scale out the backends with a simple API call. And those backends all have access to the same managed services as well as can run the flexibility of running any type of software that they want. So this really provides us this smooth continuum between platform as a service and infrastructure as a service. This is really just one spot on it. We're continuing to explore and figure out, is this the right place? Do developers want here? Do they want more and more flexibility? We're still exploring this, but this is in testing now. You guys can all get access to it. Just search for VM-based backends on the web. You'll find a Google Groups posting and be able to sign up to be a potential tester for this service. But we still are exploring that space to allow you to have the ultimate in developer efficiency while also having the ultimate in flexibility. This is what the continuum should be like. You shouldn't have to choose between the dichotomy of one of these two in order to build your applications. You should be able to get the best of both worlds. Also for you today, there are $2,000 in credits available for you for the Google Cloud Platform as a New Relic customer. This was announced just, I believe, last week as part of a partnership program between New Relic and Google. You can sign up there. There's a promo code that you enter. It's $1,000 towards regular App Engine, and then $1,000 towards Compute Engine or the VM-based backends, as well as any of the other Google Cloud Platform services such as BigQuery or storage. And this will really get you going on how to build your applications on the cloud platform. So hopefully we can all together work on finding what the happy medium is between developer efficiency and ultimate flexibility. And do you have any questions? I'm available to answer them now, or of course you can reach out to me on Google Plus or Twitter as well. Sure. In the back? Okay, so the question is, with the VM settings, can you actually configure the application that you're installing? Can you set parameters? Right now, I believe that we are at the state where you're specifying your startup scripts like apt-get, and not doing that. But what you can do, or you will be able to do soon, is to specify an image that you're running, so you can have pre-configured images with Compute Engine, and I believe we'll be able to support then any type of configuration you're looking for. This is still kind of in that tester phase. We're still trying to explore, but that's obviously something that's really important to a lot of developers. Any other questions? Going once. Going twice. All right, sold. Thank you.